everybody. It's a pop-up Monday. What's up? What's up? YouTube, Facebook. All right, let's get this party started. All right, we're going to take and go over this one here real quick. Good evening, Molly. What you doing over there? You hiding out, you little teepee? Yeah. All right, guys, here we go. Another South Jersey unit. I told you, I warned y'all. These things are going to be popping off as I'm building them. You guys are starting to see that they're really starting to like what I'm doing with this line, and it's affordable. And that's a big part of it. So this unit is a 2x8. It has two 1446 in there. There's a variable potentiometer on here. Main on-off switch, white light. 2 fan kit in this one, and each fan is 106 CFM. So they pump out a lot of air. It's actually, I think it's a perfect cooling system for this chassis. But like I said, I use my bowling alley here, throwing balls at it. I ended up doing the big old inductor coil, or tank, wire, whatever y'all want to call it. But she's tuned. She's tuned up good. So that's that. That is what the circuit looks like right there. The rest of the stuff is pretty common what I do. Got the big 6 kilovolt caps back under the transformers there, the combiners I should say, and made myself plenty of room for a nice big B plus in here. I have 3 6-gauge power wires in this unit, and then this is about the same size 16 transistor relay that we had used in years and years ago. As I say, about 10-12 years ago, we used to use the same size relay for a 16 transistor unit. So yeah, we can still use them for 16s. We can move up to the next one. It just all kind of depends. I've always believed, don't cheat yourself on your relays, guys. And some things look bigger and bulkier, and they're not always better. So you have to look at how something's actually designed and put together, and how you can manipulate it to make it work for you. As you can see, I manipulate the front of my relays quite a bit, actually a lot. I don't cut the terminals off. I actually use them as junction points. So if you're trying to figure out the best way to hook your stuff up, well, here's a little trick. So there you have that. So the bypass is tuned on there. You see the cap hanging down to ground. So the bypass tuned. Now I'm going to talk about this because I've talked to a lot of guys, and they want to use a DC box for drive an AC box. Now this is for the AC guys. The guys that have any AC box that you have input tuners on them and a plate and a load, or just a single input tuner, and takes a pretty good drive. All right, now so this goes with any AC box. The bypass tune, it has no, you can have the amplifier just sitting on a table, not hooked up to no electricity at all, and have your coax hooked up to it. And if you had a driver, let's say this one, and let's say we're going to pass this through a 16 transistor unit, but that unit is totally shut off and there's no power. So what does this signal from this amplifier have to do? It has to go from this SO239 across the bridge, right here, across this bridge. That's why we put our little trick there to make it think it's still 50 ohms at 1 point whatever 0, and then it has to come across. So it comes in here, comes across this bridge, then back over and across. There's no VOP happening right here. It's a null. So that means your standing wave would be open. So whatever you have as far as how a relay is set up in DC or AC, but AC normally has 2 relays in the box. They use one, let's say this size, for the input, and they'll maybe use both terminals, or they'll have a single relay, a half a relay like that, a single pole, or they'll dump it all together and use it as one whole relay. Now you still have to go across that bypass, and that bypass would have to go to the next relay over inside the box somewhere. And normally they'll run either a wire, a straight wire, or sometimes the guy would be smarter, he'll run coax over there, which that coax does have capacitance to it, but they're not tuning the bypass in an AC box. A lot of guys aren't tuning those properly. So the guy that gets a DC box, they'll say, oh, I got this DC box and I was talking on everything and it works great, but when I just talk on a DC box, it's showing I got a high standing wave and my reflex high and I'm losing a lot of power. And I'll tell them, go back and check the bypass tune on your AC box. Simply just take and measure. If you don't have a dummy load, just take your antenna wire off and then hook it up to your analyzer. Now, if you hook that up to your analyzer, now you can take and get a baseline of what your standing wave actually is on your antenna. Let's say it's just 1.01. All right, now you'll take and hook that back up to the amplifier, take your MFJ, take your rig expert. You don't need a piece of coax. You can, but it just, if you're trying to see what's truly happening, don't use a piece of coax. Don't direct couple your MFJ or your rig expert directly to the back of the amplifier. Now you can read the bypass tune of what the antenna is, because now you had a baseline, you had a 1.0. Now you hook this up through the box and you see that you have a 1.4 at like 60 or 70 ohms. And a DC box is not tunable, and it wants to see 50 ohms, and it wants to see under a 1.2 if you're cool. What's going on, Jay, all the way down there in Australia, Eddie? But at the end, if the box isn't tuned, the bypass isn't tuned in the box, and you are using an AC driver to drive that box, and you're talking through that box when you didn't have the big box on, you still have to talk across that bridge with your driver or your radio. So any way you cut it, if you have a high input and a bypass, not the inputs, or a high bypass on your AC box or your big box, it's going to cause problem for anybody that has any DC box in line and or a new one. I'm trying to take and cover this because I know guys are buying these boxes to run into their AC equipment. And I'm just trying to say, hey, you can yourselves can do the simple test that I just explained. And if the bypass is high in the amplifier, there's not a knob you can turn to fix it. You have to go inside, you have to figure out what capacitance value you need to trick at this relay and or at the other relay, or maybe both of them. So, and I don't have a number that is magical that would help anybody. It's something that you just have to put in the labor and figure it out. It's not very hard, and it's very safe as long as your equipment is totally drained. So keep that in mind if you're working on your AC stuff. All right, guys, enough of all that. I want to take and show you guys an O2 box, I would say, number 2. But the 8-pill I just ran the other night, I had the same inductor going on here for my input. I just wanted to make a lot of room for this 2-pill stage to come in here and have plenty of room to go in there and do what I needed to do on that, and it still leave me a nice pad room. I think I figured out a way to finally make enough room for myself inside this little smaller amplifier. So I'm happy with how it looks and the aesthetics of how it looks at this point. So let's take and toss the lid on this thing and give it a run through, and we will line it up. Let's take a look at our slugs here real quick. So we're going to be looking at a 5-watt slug input reflect going back to my radio, and then a 25-watt slug is going to show my radio. So there'd be a radio one there, and this would be the input going back to the radio. Now, radio is going to be running 14.9. I do have the R&R in here, Cobra 29. And we're going to look at 2,500 watt scale on the digital, the 1,000 and the 5 kilowatt on the analog. So let's light this thing up. And we're going to run this power supply right up here. So let's take a carrier here. All right, here we go. Now this is the unit running at minimum amperage draw. So I back the box all the way down, and this is minimum power on the amperage draw. Audio. So we're about 63 amps at 14.8. And let's look at amps here. Audio. So really close, 63, 64 amps. Now that's at minimum power. All right, that was all the way down. Let's see what my radio is punching into this. Well, let me remove my glasses. In my way. All right, let's take a look at the radio drive. Audio. Hanging out right at about 10 watts input drive. Now, these are two 1446s inside this amp. So that means it has only 2 little tiny chips in that thing. They fill up pretty quick. I told you I like these because they get excited really fast. All right, 2 chipper, audio input drive, audio, this is not input, this is input reflection at 5 watt slug. Each line is a 10, brick, small, yeah, 10. All right, so here's a 1000 watt scale, each line is 20. And we're looking at the bottom scale. Audio, minimum power, audio, 2, 3, 4, audio. So we're hanging out right around 340 on that. Now, let's just take a look at the 5 kilowatt peaker, tweaker, and a peaker, 5 kilowatt. Each line's 100 watts, audio. Hanging out right around 1200 on the peak there. Let's see what it does. RMS on the digital, Dave, audio, 3 1/4, 350, and the peaker, tweaker, peaker, audio, 1225. So that's what the unit all the way down. All right, now let's just take and speed it on up. Let's go all the way up. Okay, now the drive should be the same. Audio, 1, 2, audio. That still is. All right, input reflection, and reflection back to the radio, 1, 2, 3, 4, 5. A little over 3/10, 4/10, and here's a 1000 watt slug. Audio. Hang out at 925. Let's see what the peaker tweaker says up on the analog. Audio. Oh, that's right around 17, I'm thinking. And here, let's look at the digital RMS audio, 9 1/4, and the peaker tweaker, 50, audio, 1, 2, 3. 17, 25. Wow. Well, that's kind of all that in a nutshell. Real quick. Told you guys it was just a little pop-up. Where's Molly at? Come here, Molly. Come check this one out. So, anyway, you cut it. Nice little unit. Hold on a second. What you doing, Molly? What are you doing? Come on here. I know you're full. You said that food. You really love that food, Molly, didn't you? Huh? Come here. Molly. Come here, Molly. Come here. You're all full, aren't you? Aren't you? You just ate a big old bowl. What's up with your tongue, dude? Come here. What you got going on? You're not feeling it? You're full. You are full, Molly. That's it. None for you tonight. Still licking. I got her some of that freeze-dried food, man. She really likes it. So, there you go, guys. This one here is done and complete and going to go out after Thanksgiving, I believe. I just don't have any faith in anything getting delivered properly days prior to Thanksgiving, so I'm just going to have to hold them on the way out. But little unit turned out nice. Again, I have a 5/16 ground bolts in the back end of this thing. Everything's greased up in the back. You see that gray grease on there? That's a dielectric grease. You can wipe it off if you choose to. I'm not messing with it. This stuff is gooey. So it's going to do its job, and you're not going to have corrosion problems on your connection points and etc. I highly suggest you use that stuff on your antennas, your ground straps, everything under your truck, in your truck, if you need be. Battery terminal stuff works too. So if you got straps, you want to condition them, take some red battery spray and just saturate those straps. And if you saturate the straps, then they're going to take and it'll be rejuvenated, and you're going to be able to maintain really good ground on your mobile. But there you guys go. Little 2x1446s, 82879s. What we got? Gobble gobble, guys. Talk to y'all soon. Sliding up out of here. It'll pop up. I'm gone.